Quiz 5. I'll give you quiz 5 on Wednesday, November 16, and this is the tutorial for quiz number 5. So let's pay attention. Number 1 has to do with a few things. Sliding across uniform horizontal surface, but the force required to start an object slide. That's the important thing. Start an object slide. That means the object is at rest. That means the object is not moving. You have to apply some force to make it move. So this is subject to Fs. All right. Now the second part is that to keep the object sliding. To keep the object sliding means the other object is already in the motion. Okay. All right, so this is subject to Fk, and understand Fk is smaller than Fs. So the kinetic friction, which is Fk, is less than the static friction Fs. This is problem number 1. Number 2 has to do with Newton's third law. Fab is equal to Fba, which is equal in magnitude but opposite in direction. So in this case, I have a man, let's call M. I have a installer, let's call it S. Man push the installer, so installer push him back. So when the man push the installer by man, so installer is pushed by man, which is equal in magnitude but opposite in direction. The man pushed by installer. Okay, so the same magnitude. Newton. A good example of Newton's third law. Number 3 has to do with unbalanced force. Unbalanced force give rise to the acceleration. No unbalanced force, no acceleration. Unbalanced force always give rise to acceleration. Okay, since there is some unbalanced force, there will be acceleration. So acceleration versus time graph is always constant when there is an unbalanced force. So obviously the answer is 4. 4, we have 5 Newton force could have perpendicular component of 1 and 4, absolutely not. 2 and 3, absolutely not. 3 and 4, absolutely not. 3 and 4 will work. 5 and 5, absolutely not. So we're going to use the Pythagorean theorem and head and tail method to show why 3 and 4 are going to work. So let's call 3 and 4, let's call this one, I don't know, this one 3 Newton, and let's call this one 4 Newton, okay, 4 Newton, and they are perpendicular with respect to each other. Now let's use the head and tail. So now let's use the head and tail. So now you have the blue one, and you have the red one. Okay, now the red one is 4 Newton and the blue one is of course 3 Newton. Now the green one has to be what? Okay, so if you do the math, you will see that c squared is equal to a squared plus b squared. So c squared is equal to 3 squared plus 4 squared. So c has to be 5. So the green has to be 5. So that's why I said the answer is 3. That takes us problem number 5. Alright, so let's go to the problem number 5. Problem number 5, we have to find the normal force. So what is the weight? So there is a box sitting on the table. The box is 5 kilogram. So the weight is Fg. Fg is 49.1. Why? Because 5 times 9.81. All right, so if the Fg is 49.1, Fn has to be equal in magnitude but opposite in direction. So that means the answer is 1. That takes us problem number 6. Problem number 6 will be this one. All right, so we see this object is 10 kilogram. All right. This object is 10 kilogram. And what else we see? We see the sliding to the right. Sliding to the right, the object sliding to the right, a rough surface, acceleration at 2 meters per second. Acceleration is negative 2 meters per second due to the force of friction. What do we need to find? Find the net force. So net force is So we know the net force is F net is ma. So m is of course 10 kilogram. So this is m is 10 kilogram. So 10 times a is -2, so -20 Newton. So net force is at the direction of the acceleration. All right. So acceleration is this direction. This is acceleration. So net force is also this direction. Okay. This is problem number 6. Now we're gonna head to problem number 7. Problem number 7. We have to draw a vector. Okay, 1 centimeter is equal to 5 Newton. So 1 centimeter is equal to 5 Newton. Then how many centimeter is equal to 20 Newton? We did 20 Newton in the previous problem. All right. So Newton cancel. Newton cancel. So I have 1 centimeter over 5 is equal to x over 20. So 5x is equal to 20 centimeters. So x is equal to 4 centimeters. All right. So the answer to this question is 4. That takes us problem number 8. Problem number 8. What do we have to do? Find the coefficient of kinetic friction. So coefficient of kinetic friction is mu k is Fm over Fn. We know that Fm from the previous problem because acceleration, the net force is we saw that net force is -20. All the net force is Fn. So you're gonna take the absolute value, and Fn is, of course, this is 10 kilogram. All right. So 10 kilogram. So Fn is what? Fn is mg. This is mg. M is 10 times 9.8. Okay, so we can say 100. All right, so 100. So mu k is 0.2. All right, mu k is 0.2. All right, that takes us problem number 9. Problem number 9. 2 kilogram object falling freely. So the object is 2 kilogram is falling freely. So there's the only thing is mg. M is 2. G is I don't know. Let's say G is 10 meter per second squared. So it's 20 Newton. All right. So the answer is 1. That takes us problem number 10. Problem number 10, a force 60 Newton. So this is 60 Newton. What do we need to find? Find the friction. Our force of friction is equal to F cosine 30. And F is 60 cosine 30. All right, 60 cosine 30. So that would be 60 cosine 30 would be 52. 52 Newton. Okay, so that's 52 Newton. Number 11. All right, so what do we need to find? So in this case, this time 1 centimeter is equal to, of course, 4 Newton, and we want to know that the centimeter to draw a vector representing the normal force acting outside. So we want to find the normal force. So, all right, x is the normal force. So let's find the normal force. Normal force is 20 Newton. All right. So Newton cancel. So 1 centimeter over 4 is equal to x over 20. So 4x is equal to 20 centimeter. So x is equal to 5 centimeter. So x is equal to 5 centimeter. Okay, all right, that is number 11. So you're going to do number 12. Number 12, what we need to find? Calculate the magnitude of the frictional force. All right, so frictional force is, this is wood, all right, wooden box moving toward the right on wood surface. So wood on wood is 0.3. So frictional force FF is mu k Fn. So 0.3 times 20, Fn is 20. So 6 Newton. All right, the answer is 6 Newton for 12. Number 13. Number 13 is find the magnitude of the net force. So we know friction is 6 Newton. So net force is F net is Fa minus Ff. So Fa is 8 Newton minus 6 Newton, 2 Newton. And that's gonna take us to number 14. Number 14, we have to find the acceleration. So we know this is Ff is 6 Newton. So F net is 2 Newton. So acceleration is F net over mass. F net is 2 Newton. Mass is 20 divided by 10. 20 divided by 10, 2, right? So 2 kilogram. So 1 meter per second square. Okay. All right. So hopefully you understand that. Okay. So why did I divide that? I divide that because from Newton to mass, you just divide it by acceleration due to gravity, and then you get the mass. What am I talking about? Mass is so mass is F over A or F over G. So F is 20, G is 10. So mass is 2. That's how I get 2. Okay, good. Moving on. So number 15, what we have to determine the mass. So you have to find the mass. So mass is F over A. F is 20, A is 10. So mass is 2 kilogram. All right, that takes us number 16. All right, so we have to find. So an object weighing 2 Newton is pushed. So 2 Newton is pushed across a horizontal frictionless surface, force with 4 Newton. Okay, so Fa is 4 Newton. The magnitude of the net force acting on the object is 4 Newton because there is no force of friction. Force of friction is 0. Why? Because it says frictionless. So the total net force is 4 Newton because there is no friction. Okay. All right, that takes us to 17. All right, so if the sum of all forces acting on a moving object is 0, the object will be continue moving with constant velocity. We talk about it many times. Aristotle would disagree, but Newton would say, yeah, the object will move with constant velocity. Good. All right, so the diagram below shows the force, magnitude, okay, all right, angle theta is this. Okay, so today we did this, all right? So if, for example, if you have a mass, you have applied force 40 Newton, okay? All right, and if you have a mass, you apply force 40 Newton, all right? Okay. This is angle 0 and this is angle, let's say 30. Okay? If you increase the angle, this time, let's say this is 5 kilogram, let's say this is 5 kilogram, let's say this is mu k2 or 3, I don't know, mu k2 or 3. So this one acceleration will be very close to 6, this one acceleration will be less than 6. Okay? Of course. Alright, so 10 Newton force apply on 25 Newton object. What we need to find is force of friction. So force of friction is mu k Fn. So this is wood on wood, so this is 0.3, and Fn has to be Fg. So Fg is 25 Newton, Fn is also 25 Newton, so 25, so 7.5 Newton. Okay, so force of friction is 7.5 Newton. That is force of friction. All right, last problem, and that is problem number 20. Problem number 20, we need to find the net force. So you see that this is 25 Newton. You apply some force to move it, and then you calculated force of friction is 7.5 Newton. So the net force is equal to applied force minus force of friction, which is 10 Newton minus 7.5 Newton, which is 2.5 Newton. Make sure you understand every single problem I went over on this tutorial.